Well, I have to tell you the distance from there to there between the plates. So how long are the plates? Let's say the plates are 2 centimeters. Let's yeah, let's say it's 2 centimeters from here to here. This distance here is 2 centimeters. So how would I find the time?
So
Yeah,
it hits at 2 centimeters, basically.
it does what?
It like hits the positive thing at 2 centimeters, is what you're saying?
So it starts here at this speed, and by the time it gets here, it has traveled horizontally at a 2 centimeter distance horizontally. The distance from here to here is 2 centimeters. Whether it will hit the plate or doesn't
Yeah.
depends on the initial speed it is going and the gap between them. Yeah. So, how long will it take? Is there an acceleration in the x direction?
No.
No. Is the x component of the speed of the velocity changing? No. There is acceleration only in the y direction. So in the x direction, I can figure out what the time is. In the x direction, I know that x final is equal to x initial plus v initial in the x direction times the time, right? There is no acceleration in the x direction. So x final will be the 2 centimeters it travels. If it starts here, it's at 0. Here it's 2 centimeters. So this one is 2 centimeters or 2 times 10 to the minus 2 meters. X initial is 0. V initial in the x direction, what is the x component of velocity initially?
3.36.
3.36 times 10 to the 7th, right?
Mm-hmm.
And then times t. So we find t. We find t. It is 6.06 times 10 to the minus 10 seconds. That's how long we take it. So if I found t, I can go here and find what the final velocity is. So I got the final velocity is v initial. What is v initial?
3.36.
Times 10 to the 7. I hat, j hat, what?
I have.
I had.
Yep, only I hat, yeah. That it's moving horizontally initially. So 3.36 times 10 to the 7. J hat, I'm sorry, we said I hat, right?
Yeah.
Plus the acceleration times the time. The time is here. That's the 6.06 times 10 to the minus 10. What was the acceleration again?
8.78 times 10 to the 15.
Yes, right here. 8.78 times 10 to the 15 J hat. 8.78 times 10 to the 15 J hat. See, now the acceleration will supply you with a component in the y direction for the velocity. So you started initially with the velocity in the x direction, but at the end you will have the velocity that has 2 components. So v final, the final velocity will be 3.6 times 10 to the 7 like that, plus, let's multiply these. They will give us 0.53 times 10 to the 7 times 10 to the 7 j hat. Meters per second and meters per second. It's a velocity. Meters per second. Okay. And the final question, or the ultimate question is, what is the angle when it's deflecting? At what angle is it moving? So what is this angle? This angle here, theta. What is the angle? Oh, it's the y component over the x component inverse tangent. Yeah. So the angle, we find it by doing tangent inverse of the y component of velocity over the x component of velocity. So that's tangent inverse of 0.53 times 10 to the 7 divided by 3.36 times 10 to the 7. 10 to the 7 cancels, right? On top and bottom. 10 to the 7, 10 to the 7, cancel. This is about 9.1 degrees. And I would stop here. I somehow thought I would finish this chapter and be halfway through Gauss's law. But, I did not even finish this chapter. So Thursday, we will do motion of dipoles in electric fields. If the electric field is uniform, a dipole will just rotate, so it will experience a torque. So you might as well review what a torque means. Okay, so I will stop here. Let me pause.